my channel Learn with Nikhil. So in this video we are going to study about the equipment and the different post-processing techniques. So till now we have studied with the entire thing, like we have made the 3D model. Now what are the different techniques, post-processing techniques, and what all the changes we have to make the 3D printer or printed object a perfect object. So let's begin. So the contents will be, we'll study about the design and the process parameters. We'll study the common faults and troubleshooting, how to the faults occurring and the troubleshooting methods, process design, post-processing techniques, inspection and testing, and defects and their causes. So let's begin. So design and the process parameters in 3D printing are important considerations in 3D printing, as they are significantly impact the quality or the performance of the final printed part. So if you are making an object, a 3D printer object, so how to increase the quality of the object, or the quality of the object totally depends upon what all steps you are used, like how you are designed in the CAD, how you are transferred the file in the HTML file or in the slicer software, which all settings you have kept. All this matters so that our final product will be a good quality product. So these are the design and the process parameters. So total it is divided into the design parameters and the process parameters. So included everything, the 3D printing settings, the CAD settings, the slicer settings, all these things are included. So we'll see step by step. So first we'll go to the design parameters. So design parameters includes geometric design, orientation, wall thickness, and infill density. So the design parameters is divided into this all four parameters. So firstly, we'll go towards geometric design. So geometric design is nothing but the design which you have made in the CAD software. So how we have made in the CAD software, that matters. So this is the example of the product. So this has been designed in the CAD. How it is designed, which software is used. As for the different types of, if you are designing a machine equipment, then you have to use a different software. For jewelry designing, there is a different software. So the entire structure, the model which you are making, depends upon the which type of software you are using. Okay, so that matters. Next is the orientation. Orientation is nothing but the position of the object. So here you can see I've considered a cube. So the cube, if I have to print this cube, if I have to slice this is the slicer software. Now here for this cube, there is no requirement of support. Even if I click on the supports, if I slice this object, the time required will be 23 minutes. The filament, how much it is used, it is there. So this is how the object will be printed. Now, if I change the orientation of the object, orientation means the position of the object. If I rotate like this, now in this case, this is not a feasible design to be printed, because the surface is a smaller surface. Now it will require the supports, the time required will be more, and also the filament required will be more. So this is nothing but the wastage of the filament, and this is not will be a feasible design. So you have to select the orientation so that the filament will used will be less and the design quality will be much better. Now I'll show you one more example of the orientation. So here we have a 3D model of a human face. So for printing this 3D model, again the orientation matters a lot. Now if I slice this, this is taking around 40 minutes. This is a very small 3D object it will be printing. I'll just scale up it so that it will be better. So if I slice this before scaling up, if I slice this, this is how it will print. There will be these contours, that is the end part of the nozzle, how the layers will be formed. It will be on the head. I'll just increase the scale this size, so you will understand it much better. The contours will be visible. So if I slice this, the timing around for this entire 3D model to be printed will be around 7 hours. So I think the slicing time it is taking 7 hours 19 minutes. Filament used is also there. If I click on the preview, so this is how it will be printed. These are all the support structures, and as you can see again on the top of the head, these are the contours or the lines which will be there on the top of the head. So at the end it goes like this. Now if I change the orientation of this entire 3D model, if I'm going to print like this, so this is not the right orientation to be printed. Why? Because the support materials will be more, as this entire area which is marked in red, this will needed the supports. And if I click on the slice, as you can see, the time will increase, the materials will also be increased, as there will be a lot of supports. So material will also be increased. So these are all the support materials required. So as you can see, the contours with the end of the nozzles. So everywhere it is on the head, the nose, eyes, lips, the chin, everywhere there are these contours. So this is the end. So the finishing, the post processing requirement will be more. So this is not the feasible way to print any object. Now next we'll look towards the wall thickness. Wall thickness is nothing but the outer layer of the block. So here I have considered a cube again. So the wall thickness is nothing but how much thickness it will be the outer shell. So it is under the shell, you can see it is 0.8 millimeter thickness. Wall thickness is 0.8 millimeters. So the wall line count is 2. So the thing is that our total thickness will be this divided by this. So 0.4 millimeters is the thickness, and there will be two wall points. So zero point 0.4 thickness will be 2 times. So that will be the wall line count. So if I slice this, you can see this is the outer layer. So these are the two lines, this first line, the second line. So these are the two lines from this 0.8 millimeter. Now if I increase this wall thickness, respectively the wall line count will increase automatically. Okay, so now 0.8 millimeter is divided by two wall counts, so each wall count will be 0.4 millimeters. So this is how it is calculated. Now if I increase the wall thickness to around 1.2 millimeters, now you can see the wall line count is changed to 3. So now you can see the outer wall line count is 3, 1, 2 and 3. So likewise, you can increase the wall thickness. The much you increase the wall thickness, the strength of the object will be much greater. So the cube with higher wall thickness will be much stronger than the lower wall thickness. So here there are four outer lines as I've increased. So there will be a limit according to the size of the object. There will be the limit for the wall thickness also. So this is how it will be printed for the wall line count is 4. So I'll just increase more. If I increase the wall thickness to 3, then the wall line count will be 7. So accordingly it changes. So maximum I'm just checking according to the size how much maximum it will be. So wall thickness, if I do it like 4 millimeters, then the wall line count will be 10. So this is the maximum thickness of the wall line count for this particular size of the cube. So much more line count, more will be the strength of the object. So design parameters include geometric design, orientation, wall thickness, and finally the infill density. So infill is nothing but how much material you put inside the cube. So here you have the infill percentage. So you can see it goes from 0 to 100 percentage. So if I keep 0, there will be no infill. Inside will be, it will be entire empty. If I keep no fill, here it is around 10%. So you can see this is 10%. If I increase this to 20, 30, 40%, accordingly the infill will increase. So the more infill, the more stronger the object will be. So 60%, but you can see the material used is also increasing. The more infill, the more material will be used. 100% infill, it will be a total filled inside. So totally this object is filled with the infill. You have one more option, that is gradual infill. Gradual infill will be like at the bottom it will be lower and it will gradually increase the infill density as we move upward. So this is the gradual infill. So consider this is again a block. So block, the topmost layer, if there is no infill, it will fall because it will require some supports for the top layer to be printing. So for this type of cube to be printed, you have to go for gradual infill. The bottom part doesn't require any infill, but as we are moving up, the topmost layer will require to have the maximum infill. So the top layer will have some supports to print the topmost layer. So this is all about infill density. So this includes the design parameters. So you have to tweak the design parameters according to your need. The thing you have to keep in mind that you have to use the least material, minimal material, and you have to create a good quality object. This you can do with regular practice and a little bit iterations and changes you have to learn. Next, we'll see the process parameters. So process parameters, these are the different options in the process parameter. You have to look for the layer height, print speed, extrusion temperature, bed temperature, cooling rate, support material. So this is when you are actually doing the printing. So previous was the design. For designing, what all changes we have to do. Process parameters includes the actual thing when the printing is going out, what all things you have to keep in mind. So layer height again, same as the wall thickness, but how much will be the height of the entire object, entire layer, one layer. So if this entire cube is made up of 1,000 layers, so the height of each layer, how much that height will be? That includes the layer height. So minimal the height, maximum time will be required, but the accuracy, the smoothness of the object will be much greater. So this height is called as the layer height, first layer height. So likewise, here you can see this total object, if the is made up of like 100 layers. So each layer will have a height which is there in the around 0.2 millimeters, the height will be. So that is the layer height. Next, we will go for the print speed. So printing speed matters a lot for PLA material, also with the ABS material. So there will be effects if you are increasing the print speed very much. There will be stringing effects. The cooling will not be proper. That you have to keep in mind. So print speed matters a lot. So the settings are there in the for the print speed. That by default it is around 50 millimeters per second. That is the printing, the nozzle, from the nozzle how much material is, that is 50 millimeters per second. You can increase that to around 200 millimeters per second also. The increase in the printing speed will obviously increase some errors. There might be some errors, like the printer moves on a conveyor belt, a belt. So there will be wear and tear in the belt. There will be some noise. So there can be some issues in the printing. So you can increase the speed, but you have to just again do a trial and error method. Is it working for your object? If there are much more jumps in the object, if there are jumps in the object, then you have to keep the printing speed a bit lower side, because for the jumps then it will move very fast between the objects. If it is on a single object it is moving, then not an issue. Maximum print speed you can take, but if it is jumping from one object to another object to another object, then the jumping speed will increase much more, and there will be much more wear and tear in the object. So you have to control the printing speed. Printing speed will obviously reduce the time. It will reduce the time to around like 50%. The time will be reduced. Next is the extrusion temperature. Extrusion temperature is nothing but the temperature of the nozzle. So the nozzle temperature for PLA material, it is around 200 degrees Celsius. You can change that according to the material used. But for PLA material, you have to keep it around 200 to 205 degrees Celsius. So that is the printing speed, sorry, printing temperature. And also for the build temperature or the bed temperature, the temperature of the bed where the object will be printed. So if the object is printing, it has to be sticked on the surface. So it has to be sticked on the surface properly. So the temperature of the bed should also be maintained. So it should be maintained around 50 degrees to 60 degrees Celsius for PLA material. So that is for the bed temperature. The cooling rate also, there are several fans besides the nozzle. So the fans should be working for PLA material. All the fans should be working at 100% consistency, because it has to be cooled faster. But if you are using the ABS materials, the cooling fans should be reduced to 50. So depending upon the material used, you have to change the temperature, bed temperature, and the cooling rate. Finally, moving to the support materials. Now you know about the support materials. So this is the object, the dog shape, this is the object, and these are all the support materials which are required. So later you have to remove the support materials. So this was all about the design and the process parameters. These are the few settings which you have to, these are the few important settings I can say which you have to keep in mind. And there are more settings, but if you are moving to the complex objects, you have to look into those objects settings also. Okay, there are few settings like ZOP, you have to enable that. So depending upon the object which you are using, you have to do the practice, then you will get to know. Next is the bonding mechanism in 3D printing. Bonding mechanism is nothing but the different layers which are stick to each other. That is nothing but the bonding mechanism. So it refers to the way in which the layers of the printed part are bonded together. So the layers, each layers, how they are bonded together to form a solid structure. There are several different methods of bonding in 3D printing. So you have seen different types of 3D printers. Those are the different types of bonding mechanisms. So this is the material extrusion, the STL, stereolithography, you have photolithography. These are different types of 3D printers which can be used as a bonding mechanism in 3D printing. So this is VAT photopolymerization. You have already seen. I've explained. This is the liquid resin. So this is how the objects are bonded together. Next topic is the post processing in additive manufacturing. So post-processing in additive manufacturing refers to the additional steps or the processes that take place after the 3D process, 3D printing has completed. So once you have got the object, what all things you can do: sanding, polishing, coloring. These are all the post-processing techniques that is used to improve the physical properties, surface finish, and the overall quality of the printed part. That is called as post-processing. So now we'll see the different post-processing methods. So first one is the cleaning. So after we have done our job, the object is ready out of the 3D printer. Then first we'll do the cleaning process. So there are few printers like the resin printer, we require to keep that in alcohol. So that also comes under the cleaning process. So cleaning, surface treatment is nothing but smoothing the surface, like you have to sanding and smoothing of the surface. Any irregularities in our output, the product, you have to smooth that. Painting and coloring, so we have to go for anything you require to color your object, you have to go for that. So devices and everywhere you have to do the painting properly, so which will enhance our object and which will look good. Next is assembly. So if you have like you have to construct an whole building, so the building is a huge one, so you will make it in different parts. So assembling of those parts, so the big object you have to divide into 2-3 parts, and then you have to assemble that. For assembly also you have to like do the proper grooves, like here you can see this is not a single object, there are different parts and you have to assemble using the screws and nuts, so it is movable. So likewise, if you have to make a huge object which is divided into 2-3 parts, so internally also there should be some hooks or grooves which it will be attached together. Next is the heat treatment. So this is a very interesting object. This object, which is the lion, which is printed. So this hairs, as you can see, they were printed very straight. They were printed straight because this bending is done later. So what has happened while printing? It has printed the hairs straight. Then we have used a hot air gun, and then we have like generally combed the threads. So initially those were printed straight, and then we have like with using supports, it has been printed on the side. Like if my face is of a lion face, then using supports, all the threads are printed like this. And then removing the supports and then using the hot air gun, we have just combed our hair. So likewise, this has been made. So this is a very beautiful technique of doing this, which looks very accurate and real. Next, we'll see some of the common faults in 3D printing. So after the object is printed or while printing, there will be many faults occurring. So you have to know those faults and you have to also know how to avoid these faults. That is very important. So first one is the warping. Now, as per the image, as you can see, warping is nothing but there will be contraction from the edges of the object. So this object, when the first layer was printed, it printed properly, but later on what happened, from the edges it started to contract. Now why this happens? Now as you know the property of the material, uh, it expands and contracts while heating and cooling. So this is filament, you know, it comes out hot and later on it cools. So what happens due to heating and cooling? The expansion contraction of the material happens. So this is due to the contraction. When it cools, the material contracts. So after the contraction, this comes up. So I have one more image warping. I can so this is the nozzle, this is the filament, and this is the heat part, and this is the cool part. So if the bed level, that is the build plate, is not evenly heated, so what will happen? This part will remain cool, and if this part remains cool, then it will contract from the edges. So this term is called as warping. So this part is hot, center part is hot, and this part is cooling. Again, what happens if the object is quite heavy, or if there is lot of material in the center, more of the contraction will be at the center. So consider if the object is like this, there is a cylinder in the center and there is a flat surface. What will happen? The center part, there will be much contraction as the material at the center is very huge. So what will do? This will start contracting. So this will automatically warp. So to avoid all these techniques, you have to you have to adjust the print speed. Also, you have to adjust properly the temperature. So temperature, print speed, cooling fans, the speed of the cooling fans, everything you have to adjust properly for the smooth printing. And this you will learn by doing errors, but you will rectify that. You have to learn to rectify that. Next is so again how to avoid warping. That is, as I mentioned, level printing bed. Printing bed should be leveled properly. Use high temperature for first layer, as the first layer only tends to warp. So you have to use high temperature. So the addition to the build plate will be proper. So you have to use higher temperature for the first layer. Later you can control the temperature while working with the object. Enclosed housings for the printing. So as the outer temperature, the AC fans might affect your printing. So you have to use an enclosed housing. For extrusion printer, basic printer, the enclosing is not recommended, but you can use that. That will be beneficial. But for resin printing or the advanced printers, you have to use an enclosed environment. You have to improve the 3D model with raft and bridge. Now, what is this raft and bridge? So in Creality software, there is an option that is build plate edition. In that, you will get four options: raft, brim, none. So what happens? This brim, you can see, this is the actual object and this is the support. So this is basically, it is keeping your object flat on the surface. It is holding your object flat on the surface. So brim is this one and raft is much bigger. So you have to adjust. It is not required brim and raft, but if your object is warping much, very much, so you have to use this options which will disable the warping technique, because it warps from the edges. So even if this part warps, this part will remain proper. So basically it is increasing the surface area of its base. So it holds down to your build plate. So this is about raft and brim. You can check in the Creality software, it is there. So slicing settings you have to configure. So again, this part comes under this only. The slicing settings, like you have to control your printing speed, the cooling temperature and everything. You have to control, that comes under slicing settings. Infill density, as I mentioned, that if your infill is very much there, so more infill, more will be the contraction, as the cooling will be more at the center part, the contraction will be more, so there will be warping. So more the material, more there will be the contraction, more will be the warping. So you have to adjust the fill density accordingly. You have to reduce the print speed, as I mentioned earlier. Cooling fans have to be turned off, or you have to maintain its proper percentage. You have to cleaning the printing bed is very important. As you know, the printing bed, if it is there, there will be dust on the printing bed. And if there is more dust on the printing bed, the adhesion will not be proper. So your first layer will not stick to the build plate. So you have to clean the build plate properly. You have to use some solutions if required. And then the adhesion will be proper. It will stick to your build plate. So for adhesion purposes, you can use glues and PEI bed. This is a magnetic bed you can use, which has good adhesion. So your object will remain stick to your surface. That is your build plate. So these are the methods you can avoid warping. And this is a very common fault which I have mentioned. So next common fault is the layer shifting. So this is what happens. The layer shifting is generally due to faulty stepper motors. As you know, in our printing XYZ axis, there are stepper motors. So if the conveyor belt is not proper, it has been worn off, then what will happen? It will lose its grip and there will be layer shifting. There are many things which affects this layer shifting. I've mentioned one, that is if there is threads are removed from your motors, or the conveyor belt is worn out, then this layer shifting might happen. So to avoid this, you have to reduce the printing speed, You have to adjust the printing speed, because if the printing speed is quite fast, then if your x-axis is moving quite fast, what will happen? It will leave some gaps. So there might be some drag or drift from the stepper motors, and this layer shifting might happen. Under extrusion, over extrusion. So under extrusion is nothing but the gaps between the lines. There are gaps, too much material. If it is there, it is called as over extrusion, means more material is pumping out at few spots, it is called as over. If there is less material oozing out, that will be under extrusion. So this is basically due to if your nozzle is quite closer to the object, it will happen like this. If your nozzle is quite upward, this might happen. This is the proper smooth surface you have to get. So as I mentioned, this is due to the clogged nozzle, or this is the incorrect temperature setting. So there's a few settings which you can change and you can rectify this. Last one is stringing effect. So stringing effect is also very common thing. Stringing is nothing but if your nozzle, when it goes from one point to another, so while going from one point to another, a small thread of strings is left, because from the nozzle continuously the material is coming out. So there will be a thin thread of the nozzle, thin thread coming out. So to avoid that, we have to go for retraction. Retraction is there, but you have to do the proper retraction. How much retraction should be there? Retraction is nothing but, as I've mentioned earlier, I've explained in my previous lectures also what is retraction. Retraction is basically when the nozzle is going from one point to another. So what happens? The filament is sucked upward. So from moving from one point to another, the filament is sucked upward. So there is a millimeter of adjustment you can do, like 0.4 millimeter it sucks upward, then it goes to the other, then again the filament comes out. So but sometimes again the stringing is left if the millimeter adjustment is not proper. So to avoid that, you have to enable the retraction. Also, you have to enable the Z hop. Z hop, if it is enabled, then the stringing will be more. So you have to do some adjustments in the settings to avoid the stringing. Stringing easily can be removed later, but if it is avoided at the start only, it is better. So these were the few common faults in 3D printing. Next, we'll move toward the troubleshooting method. So this is again very important. So first you have to identify what were the mistakes happening. Next, you have to go to the troubleshooting methods in 3D printing. So when encountered faults in the 3D printing, there should be several troubleshooting methods that can be used to identify and address the issue. So I'll discuss some of the few major troubleshooting methods. So again, adjusting the print settings, slicer software, the print setting software, you have to adjust the temperature, speed, you have to do the settings properly. You have to inspect the filament. Now the filament, like if it is kept out in the normal environment, if you are not using the dehydration box, the filament property is that it attracts lots of moisture, and if the moisture is there in your filament, then there will be much of the stringing effect. So because while coming out of the nozzle, if there is water in your filament, it will evaporate, and there will be like bursting effect from your nozzle. So you have to inspect the filament properly. It should be kept in the dehydration box, so there will be no moisture on your filament, which will increase the print quality also of your uh, object. You have to review the model, like you have, after the object is there, you have to inspect it properly, whether the object is proper, it is printed proper, there are no irregularities, everything you have to inspect. And if it is there, you have to like do the sanding operation, all those things to make it proper. Cleaning or replacing printer components. Now time to time, as you know, the nozzle will worn out, the conveyor belt will worn out, the stepper motors will worn out. So as your printing quality is reduced, you have to change or replace the parts. So nozzle also you have to remove, you have to insert a small needle, is it is provided, so you have to insert into the nozzle and then you have to clean that. So that also training is required. Next is the extrusion temperature, is nothing but the temperature at which, refers to which the temperature at which the 3D printing material, typically a thermoplastic filament, is heated and melted by the printer's extruder before being deposited in layers to create the 3D object. So temperature, basically the melting temperature of the material. If the temperature is too high, the stringing will occur. So here this is the object where everything is explained properly. This is the oozing out of the filament. This is the stringing. This is the over extrusion. More filament is there. So the temperature, maintaining the nozzle temperature, the build temperature will affect your overall quality. So that you have to maintain the temperature. Finally, we are going towards our object is ready. It is printed. Now we have to inspect and test. So there are different methods for inspection. The best is human eyes. So inspection and testing methods are essential for ensuring the quality and accuracy of the 3D printer. Some of the most common inspection techniques, as I mentioned, first one is the visual inspection. So visual inspection is the inspection which is done by the human eyes. You have the vernier caliper here, digital vernier caliper, which will measure the dimensions are accurate or not. If it is accurate, is it pass? If it is not accurate, then you have to redo the things, or you have to do the sanding operation. You have to get the proper dimensions. The dimensional measurement is also recorded in this. So visual inspection, dimensional measurement. Next is the mechanical testing. So you have to test the total strength of your object. So the samples are printed, and then using the machine, you have the force is applied, and with the force, when it breaks, you'll get to know how much the force your object or material can withstand. So this is the mechanical testing, or it is also called as the material testing. Next, you have to go for the X-ray inspection. So internally, if there are any defects, so this is the engine which has been printed. This is the metal. So internally, internal parts, you have to see whether they are printed properly or not. So you have to go for the X-ray. X-ray, CT scanning, spectroscopy are one and the same to see the internal parts, the porosity. This is the electronics inspection, dimensional measurements. Inside we can't open and see. So it is entire object. So internally, what is it printed properly or not? You have to go for this X-ray, CT scanning, spectroscopy to find the proper. Again, CT scanning, you will get the entire object, the quality, the printing you can see internal. So these are the different methods of inspection and testing in 3D printing. So with this, we have done entirely with our 3D printing. So we saw how to print the object, the inspection, the post-processing, start to end, how to generate the file. So this was everything theory part of 3D printing. We'll move towards more of the practical sessions also. You'll see practically how to bed level and everything. We'll keep learning. Thank you so much. We'll see you in my next lectures.